What happens when an application you developed becomes popular? In that case, you will have much more traffic in your network. So, how do you handle that much growth? The answer is scalability. We have to design our applications and platforms with scaling in mind. Today, we will discuss about how to design our systems so that they are scalable. As your application grows, you need to add more and more resources to serve the increased traffic in the incoming requests. So your service or application is scalable if it can do more units of work on adding more resources. This can be done in two ways. The first one being vertical scaling. Vertical scaling means adding more capacity or processing power to your existing server so that it can handle more load, like adding more RAM, more CPUs, etc. But this can be done only to a certain limit because it becomes too expensive and it will be single point of failure. So, what's the solution? That's where we have horizontal scaling. In horizontal scaling, we add more servers in the network, which have exactly same code base and they do not store any user-related data like sessions on local disk or memory. Because such information needs to be stored in a centralized data store, which is accessible to all your application servers. Now, once we have multiple servers, the incoming requests can be distributed among them. This can be done using a load balancer. A load balancer will take your incoming requests and assign them to application servers based on some algorithms such as round robin, random selection, or it can be more dynamic like assigning based on load of application servers. We see here we have clients and then clients send their request which come to load balancer. You can have either you can have software load balancer or you can have hardware load balancer. And when the requests come to load balancers, these are assigned to your application servers based on the algorithm you are using. If we have only one database, then that can be your single point of failure in our network. To address this, we can have data replicated across multiple databases servers, and that can have master slave configuration. All the write requests must go to master server and data must be replicated across all slaves. This way, any of these slave servers can serve your read requests. So let's see how our system looks like with all this design. So here we have our client network. Client requests come through load balancer, and these are directed to different web servers based on the load balancing algorithm you have. If those are the read queries, those go to its database using a load balancer. And if it's a write query, that goes to master database. And then data is replicated to all the slaves. So what's the problem in this design? So the problem in this design is what if your master itself goes down? In that case, we can promote one of the slaves to master, but it will take some time. And our service will be supporting only read requests during that interval. So what can we do here? So in this case, we can go with master-master configuration where we have two masters. And in our code, we can have logic to always connect to, let's say, master one. And if your master one, for some reason, is not responding to connection request, we can switch to master two. That way, we can better handle the failure in our network. Now, let's see what other problem we see in this network. What can be single point of failure? If we see we have only one load balancer at a level, so this can be a single point of failure. So to solve this problem, we can have pair of load balancers where if one load balancer fails, the other load balancer can take over. Now, all of this network which we have will be located at some site where we'll have all our servers. So what if there is an issue with that site where we all have all this network? Then our entire system will go down. To solve this problem, you can have same network at multiple places. That's what data centers are. So you can have multiple data centers with same network design so that if one data center goes down, the other data center can take over. So how do we distribute requests among data centers? We can do this based on some geographical based load balancing so that request from a given region goes always to a specific data center. Only if there is some issue with that data center, we try to go to some other data center. Now, as our database size keeps on growing, as your application sees more and more growth, we will see a lot more data in your network and your queries are going to be slower with time. So how do we handle that issue? In that case, we will have to introduce caching layers. We can cache the data For example, we can cache the query and its response. So let's say if next time same query comes and data in the corresponding tables then changed, we can return the same data and it will be much faster. So that's all for this video, like from design, how we can design a system to be scalable, where we discussed about having code base replicated across multiple servers so that we can distribute load. And similarly, we can have multiple clones of database as well so that we eliminate database as single point of failure. And we can also have multiple, like a pair of load balancers. So you just try to eliminate single point of failures in your network so that your network is performing well at all the times, even in case your one server goes down, other server can take over. That's all for this video. Hope you have learned about how we can scale our application as traffic grows. If you like this video, please like, share, subscribe to my YouTube channel. Thank you.